Have you ever really looked at a glass of wine and just wondered, what is actually going on in there? I mean, beyond the beautiful color and the inviting smell, there is a whole world of chemistry at play. So today, let's uncork the science behind your favorite vintage.
Yeah, at first glance, it's a lovely glass of red wine, right? But what you're looking at is so much more than just fermented grape juice. This liquid is a complex mixture, a total transformation of something simple into something far more intricate. It's really a story told through chemistry, and we're about to dive right in.
So, that brings us to the big question for this explainer. What is actually happening on a molecular level inside that glass? We're going to break it all down, from what gives wine its sweetness and its structure, all the way to what creates its unique feel, color, and aroma.
All right, so to really get it, we've got to take it apart first. Let's peel back the layers and see what wine is fundamentally made of.
Now, this might actually surprise you, but the vast majority of what's in your glass, we're talking up to 95%, is just water. The real magic, the whole story, is in that last little bit. It's everything that's dissolved in that water. The sugars that act as the fuel, the organic acids that give it that kick, the polyphenols that create color and texture, and so much more.
So how do we get from that, watery grape juice to the wine we all know and love? Well, it all kicks off with one big transformation, turning sweetness into structure.
Okay, so the journey starts with sugar, specifically two main kinds you find in the fresh grape juice, or must, glucose and fructose. Fun fact, fructose is actually much sweeter to our taste buds. But their most important job isn't just about making the juice sweet. No, they are the absolute essential fuel for the engine of winemaking, fermentation.
And this is where the real magic happens, fermentation. It's actually a beautifully simple three-step process when you break it down. First, yeast gets introduced to that sugary must. Second, the yeast just goes to town, feasting on all that glucose and fructose. And finally, in return for that meal, it gives us the good stuff, alcohol, carbon dioxide, which is what makes sparkling wine sparkle, and a whole host of other compounds that begin to build the wine's complex character. Okay, so now we've got alcohol and we've got structure. But what about how the wine actually feels when you drink it? You know, that sensation in your mouth? Well, that all comes down to two key things, acidity and astringency. You know that zesty, almost mouth-watering feeling you get from a really crisp white wine? Yeah, you can thank organic acids for that. The three big players are tartaric, malic, and citric acid. But they don't just provide that fresh, sharp feeling. They also set the wine's pH, which is absolutely crucial for keeping the color stable and even protecting it from going bad. But here's the thing. Not all acids are created equal. The two main ones kind of have their own distinct personalities. You've got tartaric acid, that's the powerhouse, the strongest one. At low temperatures, it can sometimes form tiny, completely harmless crystals that some people call wine diamonds. Then there's malic acid, which is softer. What's fascinating about this one is that it can be transformed by bacteria into an even softer acid called lactic acid. Yep, the same acid found in dairy. That process, called malolactic fermentation, is a big reason why many red wines have that rounder, creamier feel.
All right, let's talk about that other key feel component, astringency. This quote pretty much nails it. It's that dry, puckering feeling you get, especially from a young, bold red wine. It's caused by compounds called tannins. If you want a good comparison, think of drinking a really, really strong cup of black tea with no sugar or milk. That feeling, that's astringency. What's literally happening is that tannins from the grape skins and seeds are binding with the proteins in your saliva, creating that distinct textural sensation.
Okay, so we've covered taste and feel. Now let's dig into the chemistry of what we see and what we smell, the color and the aroma.
So, those beautiful ruby and garnet hues you see in red wine, that is pure chemistry in action. They come from compounds called anthocyanins, which are extracted from the grape skins. And what's incredible is how sensitive they are. In the high-acid environment of wine, they show up as red. But, and this is wild, if the wine were neutral on the pH scale, those same compounds would turn a greenish-black. You're literally looking at a natural pH indicator in your glass.
And what about aroma? Well, that's a complex bouquet that's actually built in three distinct stages. First, you have the primary aromas that come from the grape itself. Think fruity, floral, and herbal notes. Second, you have the secondary aromas, which are created during the fermentation process, like yeasty or buttery scents. And finally, you get tertiary aromas, which only develop during aging, giving us those complex notes of leather, tobacco, or nuts. The crucial thing to remember is that what you're smelling is a symphony of all three working together.
All right, we've talked about the big players, the stars of the show. But our story really isn't complete without the supporting cast. These are the chemical components working behind the scenes to make it all possible.
First up is nitrogen. The vine pulls it up from the soil, and it becomes the primary food source for yeast. It's really simple. Without enough nitrogen, the yeast starves and the fermentation just stalls. It is absolutely fundamental.
Next, we have minerals. These are trace elements like potassium, calcium, and iron that get absorbed from the earth by the vine's roots. Now, they're only present in tiny amounts, but they really do contribute to the wine's balance. And remember those wine diamonds we talked about? Well, potassium is what combines with tartaric acid to form them. See? It all connects.
Vitamins also play a super important role. Take vitamin B1, for example. It is absolutely essential for the yeast to multiply properly. But here's the thing, most of it gets consumed by the yeast during fermentation, so very little actually ends up in the finished wine.
And finally, we have enzymes. Think of these as the tiny project managers of winemaking. They're catalysts, which means they speed up crucial chemical reactions, like the browning that happens when a wine is exposed to too much oxygen, without getting used up themselves. They just make things happen faster and more efficiently.
So there you have it. We've journeyed from sugar and water all the way to acids, tannins, and aromas. We've seen how a simple grape becomes this complex chemical tapestry. And this brings us to our final thought. The next time you pour a glass of wine, just take a moment, swirl it, smell it, taste it, and ask yourself, now that you know the science inside, what new story will it tell you?